Okay, let's see some examples now. This is a x less than a particular value. So if we remember how to break this down into without its modulus, we'll know that it has to be broken down into two continuous functions. And a can be an expression. So in this case, 2x minus 3 is going to be my a value. And I can rewrite this as such. So remember the other side is a negative a, so which means negative 2x minus 3. So this is how we are going to solve it without its modulus. And this is called a continuous function because it lies between two particular values, one in its negative to its positive. So we have to solve them separately. So we are solving an AND inequality, which is going to be important later on. So let's solve the left-hand column. So I make x the subject, bring them all to the right-hand side, and divide it both sides by 3. So I get a x greater than 1. So let's do the right-hand column. Similarly, I bring all the x terms to one side, and I solve x as greater than 3. So now because this is an AND function, so we have to take a look at AND is similar to having to fulfill both conditions. So both must be fulfilled. Both sides, the output from both, or rather the conditions from both sides needs to be fulfilled. That's the meaning of an AND function. So if I say x is greater than 1, so I'm talking about this set of value that does not include 1. I need to accept all the other values greater than 1. So 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So on this other side, when x is is greater than 3, so I'm going to take values that's greater than 3. So eventually, which is the set of solution that fulfills both? So I'm talking about the intersection of the two conditions. And so eventually this would be my final solution set. Okay, so similarly, let's practice what happens if I'm solving a fx function and it's a greater than a, for example. So in this case, I'm going to break it down into two segments. Fx can be without its modulus, so I'm going to rewrite it without its modulus, greater than, or fx is going to be a less than a negative a. So in this case, what is my fx? My fx is my expression 2x plus 5. What's a? A is going to be 4. So this is how we are going to break this into two discontinuous inequality and solve them separately. So I'm going to solve them separately. So this is how I rewrite them. So this is based on the definition of a modulus function. So I'm going to solve the left-hand side, manipulate, make x the subject, and this being a linear form is quite easy to solve both sides. So now this being an OR function, it's quite different. OR means I can take either fish or chicken. So I can take both, isn't it? So if I eat vegetables, I eat carrot and potato, means I can eat both. So then in this case, what would my final solution set? It would have to include both. So that's also quite straightforward. Sometimes you will see inequalities of such nature, and this really would be the simplest to solve, in fact. Unless, of course, it ends up being a lot more complex after we use the method I'm going to introduce to you. You realize that the left-hand side, the right-hand side, they are both positive, right? They are both positive. So 4 times the modulus x minus 3 is definitely positive. So what this means is we introduce a trick that you could use to solve modulus inequalities like such. We square both sides if you are very certain that both sides are positive. So that's a check that you need to make. So when we do that, we can just remove its modulus and treat it as an expression, an algebraic expression, expand them as such, and ta-da, what did we get here? We got an inequality with we solve for a quadratic function really, isn't it? So in a quadratic function, we solve it like we did before and check for the roots. And in this case, remember your sign test. So there are two roots over here. We have 12 over 5, 12 over 5, and we have the value, the root 4, isn't it? We solve for two roots, and this being a negative quadratic form, I'm going to start with a negative, toggle minus plus minus, and because we are solving for a less than 0 function, so which means I'm taking these two segments as my solutions, and then this would eventually be my solution here and greater than 4 over here. This we learned before. If you have forgotten, please revisit the videos about solving polynomial inequalities.